What's up, guys? It's Mr. Pringle, and today we're going to be going over the distance versus displacement concept builder from physicsclassroom.com. I'm going to be going through one question from each of the trophies, and you should be able to get all of them done after seeing a couple examples. Let's start with the apprentice level. So the purpose of this concept builder is to tell the difference between distance and displacement. And the first thing we're going to always do is find the distance. And it says a quarterback backpedals 2.1 meters north, then runs 7.4 meters south. So when we're solving for distance, distance is the total path that's traveled. So it doesn't matter which direction the person or the object moves. It's just about how far they went. So for this problem, distance is going to be equal to 2.1 meters plus 7.4 meters. Okay, so this is going to end up being 9.5 meters of total distance here. And I will need to switch over here. So we'll put in 9.5. Okay, now displacement is a little bit different because displacement includes direction. So we have to take that into consideration. And since displacement is a vector quantity, that means that we're going to need to add vectors that are in the same direction and subtract if they're in opposite directions. So notice here that in this problem, it says 2.1 meters north and then 7.4 meters south. So we have two different movements here in opposite directions. So basically, if we kind of draw a little map here, we could show that the quarterback moves, up 2.4 or 2.1 meters, right? And now that they're at this point here, but then they move backwards at 7.4 meters. So basically what we're interested in is finding the distance of this dotted line here. That's how far away did the person end from that starting position, right? So displacement is the straight line distance between the starting and ending positions. How far was the person displaced from their original position? So we're going to need to do 7.4 minus 2.1, which is going to give us 5.3. And that's what you're going to put into the magnitude here is 5.3. Magnitude just means how much. And then the direction would be, which direction did the person end up moving net? So yes, they moved north, but ultimately there was more movement south. So the person ends up 5.3 meters south of the original position that they started in. Okay, so this distance right here, if I can go back to my, this distance right here is going to be 5.3 meters. And we'll go ahead and check our answer. Okay, great. Let me clear this. And so the first level is only going to have two movements. It might be east, might be west, might be north, south. So that one shouldn't be too bad. They're always going to be in opposite directions there, so you'll complete those the same way. Now, when we return to the main menu, you'll obviously complete the whole trophy. Let's go into the master level. Now it's added a third movement in here. So this time it says a cross-country skier moves 36 meters east, then 44 west, and then 22 east. I'm going to underline the east, and I'm going to circle the west so that we know that those are different. So again, with distance, we're simply going to add all of these up together, all of the movement. It does not matter which direction. So 36 plus 44 plus 22, and that's going to give us a total distance covered of 102 meters. Okay, and you don't need to put meters in because it's got it right here. All right, now it says what's the magnitude and direction of the displacement. So again, let's kind of draw our little map here. So it says that it's 36 meters east. So let's say the person starts here on this red line. They move 36 meters east. Then they go 44 meters west. So they're going to end up a little bit to the left of that line that they originally started on. And then 22 more meters east. So they would come back this way some distance, 22. meters. Okay, so again, what we're trying to figure out is how far away, basically the person ends up right here on this dot, right? So we're trying to figure out the distance from the original position to that dot. So what we're going to do is, since we have two movements that were to the east, we're going to add those together. So for the east, we have 36 plus 22 meters. And then we're going to need to subtract the westward movement, which is 44 meters. So we'll erase that there. Okay, so we'll add up. We'll go ahead and do 36 plus 22, and then we're going to, which is 58 minus 44, and we get a net movement of 14 meters to the east. And I would encourage you to draw a diagram like I have each time. It might be a good visual for you, but you can see that the dot ended up to the right or the east of the line that we originally started on. So the other thing is obviously the eastward movement here, which is 58 meters total minus 44 meters. That's going to, there's obviously more eastward movement than westward movement. Okay, so we'll go ahead and we will check our answer here. And we get it right, which is great. We'll clear this. And let's do one more example on the wizard level here. This time it's going to have 4 movements. So definitely have to be careful here. It says a football coach walks 10 meters east, then 18 meters west, which again, I'm going to circle those, then 22 meters east, and then 34 meters west. Okay, so again, for distance, we're just going to add all of these up. So we'll do 10 plus 18 plus 22 plus 34, and we get a total distance of 84 meters. Now we need to figure out the displacement. So once again, we could draw a little diagram here. Let's say that we start here on this line, and it says that the person goes 10 meters to the east and then 18 meters west. So they are going to end up a bit this way. Then it says 22 meters east. So back this way. And then 34 meters west, back this way. So we can see here, this would be eastward movement, this would be west. We can see here that we're going to end up with a net direction of west. Let's go ahead and figure out what the displacement is by taking our, I'm going to start with the west over here because we know that we're going to have more west than east. We're going to do the westward movement minus the eastward movement. And so that's going to be 18 meters plus 34 meters of westward movement minus 10 meters plus 22 meters of eastward movement. Okay, so we'll go ahead and add these up. And we'll get, so there's 52 meters of westward movement minus 32 meters of eastward movement, and that's going to give us a net movement of 20 meters west. Okay, so that one's obviously a little bit more complicated because you've got 4 different sets of movement. So make sure that you add the ones that are in the same direction and then subtract the ones that are in the opposite direction. Now, if you were to start with eastward movement and do, 32 meters minus 52 meters, you're going to get a negative number. Just understand that because you're including the direction, you don't have to put a negative number in there because we're including the direction right here. So you'll just take the absolute value if you end up doing that, which is just the positive version of that number, and then you're going to indicate the direction right here. So 20 meters west is our final answer, and we do get that correct. So there's one example from each of the trophies on the distance versus displacement concept builder. You will complete all 3 trophies. Let me know if you have any questions.